First up, let's talk about how all these devices actually talk to each other. And no, it's not telepathy, at least not yet. We're talking wireless communication technologies. You've definitely heard of some of these: Wi-Fi, Bluetooth, maybe even Zigbee. These are like the languages of the IoT world. Wi-Fi, you know it, you love it, great for high bandwidth stuff, streaming, downloading, that kind of thing. Bluetooth, your go-to for short-range connections like headphones, smartwatches, that sort of deal. Zigbee, now this one's a bit more niche, super low power, perfect for those devices that need to run for a long time without draining the battery. Then you've got the heavy hitters for long-range, wide-area networks, LoRaWAN and cellular technologies like 5G and NB-IoT. These are the backbone of large-scale IoT deployments. Think smart cities, industrial automation, that kind of scale. Each technology has its own strengths and weaknesses, kind of like choosing the right tool for the job, and the right choice really depends on the specific application.
Now, communication is cool and all, but without the ability to sense and interact with the physical world, IoT wouldn't be nearly as impactful. That's where sensors and actuators come in. Think of them as the eyes, ears, hands, and feet of the IoT ecosystem. Sensors capture data from the environment, things like temperature, humidity, light, pressure, even sound and motion. They're constantly collecting information, feeding it back to the system. Actuators, on the other hand, are all about action. They take instructions based on the sensor data and actually do something physical. This could be anything from turning on a light or adjusting the thermostat to controlling a robot arm in a factory. The combination of sensors and actuators is what allows IoT systems to respond dynamically to changes in the environment and make real-time decisions. It's like the difference between just observing something and actually being able to interact with it and change it.
Okay, so we've got devices talking, we've got them sensing and acting, but what about processing all that data? Traditionally, everything would be sent up to the cloud, but that can get pretty congested, especially with millions, even billions of devices coming online. That's where edge computing comes in. Instead of sending everything to a central server, edge computing processes data locally, right there on the device or on a nearby server. This has some major advantages. First off, it reduces latency, which is the time it takes for data to travel back and forth. Less travel time means faster response times, which is crucial for things like real-time monitoring and control. Second, it reduces the amount of data that needs to be sent to the cloud, which can save on bandwidth and storage costs. And finally, it improves privacy and security by keeping sensitive data closer to the source. Edge computing is all about making IoT systems faster, more efficient, and more secure. Chapter 4. Cloud Computing, the brains of the operation. Now don't get me wrong, the cloud still plays a massive role in the IoT world. Think of it as the brains of the operation, the central hub where all the data comes together for storage, analysis, and long-term decision-making. Cloud platforms like AWS IoT, Microsoft Azure IoT, and Google Cloud IoT provide the infrastructure and services needed to connect, manage, and analyze data from millions of devices. They offer a wide range of tools and services, everything from data storage and processing to machine learning and artificial intelligence. The cloud is where you can really start to unlock the true potential of IoT data, identifying patterns, making predictions, and gaining insights that wouldn't be possible with traditional data analysis methods. Chapter 5. AI and ML, Making IoT Smart. Speaking of data analysis, let's talk about AI and machine learning. These technologies are what truly make IoT systems smart. AI and ML algorithms can analyze massive amounts of data from IoT devices, identify patterns, and make predictions. This enables things like predictive maintenance, where the system can anticipate equipment failures before they happen, or personalized experiences, where devices learn your preferences and adjust accordingly. Imagine your smart home automatically adjusting the lighting and temperature based on your daily routine, or your car suggesting the optimal route based on traffic conditions and your driving habits. That's the power of AI and ML in the IoT world. It's about making systems more proactive, personalized, and ultimately, more intelligent.
Chapter 6. Big Data Analytics, Finding the Needle in the IoT Haystack. Now, with all these connected devices generating mountains of data, we need a way to make sense of it all. That's where big data analytics comes in. Big data analytics is all about extracting meaningful insights from large and complex data sets. In the context of IoT, this means analyzing data from millions of devices to identify trends, patterns, and anomalies. This information can be used to improve efficiency, optimize operations, and even create entirely new business models. For example, a smart city could use big data analytics to optimize traffic flow, reduce energy consumption, or improve public safety. The possibilities are pretty much endless.
Chapter 7: IoT Platforms, Connecting the Pieces. So we've got all these different technologies, but how do they all work together? That's where IoT platforms come in. Think of them as the middleware, the glue that connects all the hardware, software, and networks that make up an IoT ecosystem. IoT platforms provide a centralized dashboard for managing and monitoring devices, collecting and analyzing data, and developing and deploying IoT applications. They offer a wide range of features, including device management, data ingestion and processing, analytics and visualization, and security and authentication. Some popular IoT platforms include AWS IoT, Microsoft Azure IoT, and Google Cloud IoT, just to name a few.
Now, with all these connected devices, security is more important than ever. Cybersecurity technologies are crucial for ensuring that IoT systems are protected from unauthorized access, data breaches, and other threats. This includes everything from encryption, which scrambles data to make it unreadable to unauthorized users, to blockchain, which provides a secure and tamper-proof way to track and manage data. Other important security measures include secure boot, which ensures that devices only boot up with authorized software, and device authentication, which verifies the identity of devices trying to connect to the network. As IoT continues to grow, cybersecurity will become even more critical for ensuring the safety and reliability of this.
Now, let's talk about RFID, or radio frequency identification. This technology has been around for a while, but it's playing an increasingly important role in the IoT world, especially in areas like logistics and supply chain management. RFID uses radio waves to track and identify objects wirelessly. An RFID system consists of two main components: tags, which are attached to the objects being tracked, and readers, which emit radio waves and receive signals back from the tags. RFID tags can be passive, meaning they don't have their own power source and rely on the reader's signal to power them, or active, meaning they have their own battery and can transmit signals over longer distances. RFID is used in a wide range of applications, from tracking inventory in warehouses to managing access control in buildings. Finally, let's talk about power. One of the biggest challenges in IoT is ensuring that devices can operate for extended periods without needing their batteries replaced or recharged. That's where energy harvesting and low-power technologies come in. Energy harvesting is all about capturing energy from the environment, such as solar, wind, or even vibrations, and converting it into usable electricity. Low-power technologies, on the other hand, focus on designing devices and components that consume minimal amounts of energy. This includes things like low-power microcontrollers, energy-efficient sensors, and optimized communication protocols. By combining energy harvesting and low-power technologies, we can create IoT devices that can operate for years on a single charge or even indefinitely without any external power source. So, that's a wrap on our deep dive into the top 10 enabling technologies of the IoT world. From wireless communication and edge computing to AI, cybersecurity, and energy harvesting, these technologies are working together to create a more connected, intelligent, and efficient future. As the IoT landscape continues to evolve, we can expect to see even more innovative technologies emerge, pushing the boundaries of what's possible and transforming the way we live, work, and interact with the world around us. Thanks for watching. If you found this video helpful, don't forget to like, share, and subscribe for more tech insights. See you in the